Today we are going to discuss how NLP is going to be used to perform the task of information retrieval. At the end of this session, a student will be able to demonstrate how natural language processing techniques can be used for developing information retrieval. Information retrieval is an activity of obtaining material that can be documented on unstructured nature. The software deals with organizing, storing, retrieving and evaluating information from textual documents. It is a dominant form of the information access. It assists in finding information required but does not answer the queries of a particular user. It notifies the location of documents containing the information and extends support to browsing and filtering of documents. When developing such an information retrieval model, it selects the ranks document as requested by a user through a query. These documents and queries are matched using a matching algorithm which calculates a function which is called as the matching function output, and this is a retrieval status value which is returned for each document. A query is made of terms from a defined vocabulary which may consist of more than one words or terms from the specified vocabulary. There are various types of information retrieval models. The first one is based on the mathematical basis, which is set theoretical, including standard Boolean, extended Boolean and fuzzy retrieval. The second is the algebraic systems, which are vector space, general vector space, enhanced topic based vector space, extended Boolean and latent semantic indexing. Then we have the probabilistic models, which are binary independence, probabilistic relevance, uncertain inference, divergence frame randomness, language models and the latent direct. The second sort of models are based on the properties of the model, whether the model is without term dependencies, where we treat different terms or words as independent. Then we go for models with intermittent term interdependencies, which allows a representation of interdependencies between them. Then we have models with transient term interdependencies, which allows the term interdependencies but not alleged how the interdependencies between the terms is actually defined. Now let's pause for some time and think how this NLP could achieve all the activities that are specified for information retrieval. We go for understanding this by our basic model, which is our vector space modeling, which is a way of representing textual data as a high dimensional vector in the mathematical space. Each dimension is a different term or a word in the text, and it is often used for text classification, information retrieval and natural language processing tasks. It helps to identify similar or related documents based on similarity of the vectors in the space. Name entity recognition is one of such a model, where it is a subtask of natural language processing involving identifying and categorizing the named objects of the interest in the text. It is used for various purposes like text summarization, question answering and machine translation. It helps to identify the exact relevant information from the text. To build such an NER system, we follow a particular process, And this process involves identifying the key information in the text and classification into a set of predefined categories. An entity is an object of interest. NER has two-step process. One is detection, and after detecting, we go for placing that particular entity into a class called as classification. Some categories of NER are the person, the organization, a place, or a location. The steps to be followed for the building process of NER are: first collect data, then pre-process this particular data, annotate this particular data, feature extraction, model training, evaluating the particular model is then tuned and then deployed. Ambiguity has definitely to be addressed when considering name entities. There are various methods to generate these models of name entities. So the first model is train the model for multi-class classification using ML algorithms. It requires a lot of labeling, lots of deep understanding and context and dealing with ambiguity. Therefore, deep understanding and ambiguity consumes a large amount of time. This becomes a challenging task of dealing with to get the result relevant to a user. The second method includes the use of the conditional random field implemented in natural language processing, speech tagger, and NLTK. Here we use probabilistic model where sequential data comes into existence and we can capture deep understanding and the context of a particular sentence. The third method includes the use of deep learning, which is more accurate and capable to assemble words. It uses word embedding techniques of natural language processing that is capable of understanding semantics and syntax relationships between these words. It also analyzes topics specific as well as high-level words automatically. Deep learning does such repetitive tasks itself and hence is the best to be used for developing NERs. We use SPACY and NLTK frameworks for the implementation along with Python. Evaluating such systems for their entities becomes a question of concern. The tagging can be useful. It allows very large raw text to be tagged, and we can use network graphs. These network graphs also have specificities which we have to keep into account, like considering the NER solution selection criteria and the environmental and the entities associated. Then we go to understand the test corpora, then the evaluating of the matrices based on machine learning using precision, recall, F measure, and finally the time for the complete corpus and each entity. Then we go for general tagging, entity specific tagging for a corpus, and entity specific tagging for articles associated to get the relevant results for a user. Here we have to keep in mind that computational speed is very important, which involves the time for tagging, uploading models, correctly identifying and classifying the named entities in the text. We use parameters like accuracy, specificity, and sensitivity to give us the best results as compared to what we could achieve from previous models. Relational extraction has to be considered, which is a natural language processing task to identify semantic relationship between entities mentioned in the text. Relationships are considered between two or more entities in a sentence. The binary relationship extraction is done, and this involves the existence of the words we are interested in and which words we are not interested in. We also can go for high order relation extraction, which gives us better results. Reference resolution is another concept that we require to do using NLP for information extraction, which involves identifying the linking pronouns, noun phrases, and other entities in a sentence or a document to the entities they refer to. The main goal is to accurately identify entities referred in order to improve understanding, because a user requires relevant information to understand what these particular entities are actually defining. The correct interpretation of referring these particular expressions at a proper state and the methods used are rule-based approaches, machine learning models, and deep learning models. We typically involve analyzing grammatical structure of a particular sentence, which tells us accuracy and correctness of the particular language vocabulary. We then go for co-reference resolutions, which could be an NLP task involving linking all the mentions of the same entity within a given text. We identify words, phrases which refer to the same entity. We identify the entity, and once we know that the use of this particular entity and its similarities, we form cluster together with all the mentions of this particular entities. We deal with ambiguous references referring to multiple entities. The next concept is not to stick to a single natural language, but to go across lingual information retrieval using multiple languages. We use the translational approaches for translating the documents from one language to the other as required, translating the query, translating the terms in the particular query, giving synonyms for the particular terms in the query. We might create a pivoted language or interlingua, which consists of more than one languages expressed in a particular scenario. We can do all these things very efficiently, and hence most of the information retrieval tasks could be very well accomplished because natural language processing algorithms have supported it to happen. For our references, we have used Alan James, Natural Language Understanding, Bird, Clean and Looper, Natural Language Processing with Python. Thank you.